So, welcome to Sundar's lecture. This is lecture number 28, and in this lecture, we are going to solve another problem, right? So, in the last class, we have seen a star to delta connection, right? So, you see here in the last class, we have taken this problem and we have found what is find that means resistance between point E and F, and here you see there is a star connection and we have converted that star into delta connection and we have found what is the equivalent resistance between point E and F, right. So you see in this circuit, if you convert this star to delta, then the circuit looks very simple, right. So then we have simplified this circuit with the conventional methods, that is there is no problem after solving the conversion of star to delta connection, right. So it is very simple. So this is the given circuit and we need to find what is the resistance between point A and B. And you see this circuit, just I will explain you. See, this is 4 ohms resistance, this is 8 ohms resistance. How these two resistors are connected? See, one end is connected. See, one end is connected, but the other two ends are connected to a different point. But so these two are connected in series. By our whatever the things we have learned, if one end is connected, then we can assume that those two resistors are connected in series. Okay, fine. Then these two are connected in series. Then if I simplify these two, I will get 12 ohms. But I will connect one end here where I need to connect another end to this point or to this point. That is a very big question comes here. See, I cannot connect another end. If I connect here, then what happens to this end? So that is a problem. That is a problem. So for so you see this circuit is looks like delta connection. So we convert this delta into star, then we see how the circuit looks like. It is very simple, right? So for that, you see here they didn't give any ABC parameters, ABC points. So you need to assume the points, right? So what I will do, I will assume this as A because this has to be A. This has to be A, and I am assuming this is B and this is C. See, we need to take which is R1, which is R2 and which is R3 now. For that, you see I have told you this has to be R1, this has to be R2, this has to be R3 in the beginning itself. See, between point A and C, the resistor connected is R1. Between A and B, the resistor connected is R2. That is the thing you have to understand. Between A and C, it is R1. Between A and C, it should be R1. It should be R1, right? Then A and B, that should be R2. And between B and C, it is R3, right? Am I right? Okay, fine. I'm right, right? So now we can write this as let us rewrite the values of R1, R2, R3. So R1 that should be equal to 4 ohms, R2 that should be equal to 8 ohms, and R3 that should be equal to 6 ohms, right? So we have written the values now. Now if you want to convert star to delta, sorry, delta to star, then what is the formula? You need RA, RB, RC, right? In terms of R1, R2, R3. So you see here we have formulas. So RA, RB, RC, that too in terms of R1, R2, R3. In denominator it will be what? R1 plus R2 plus R3. In numerator it will be RA means R1, R2, RB means R2, R3, RC means R3, R1. That's all right. So we will substitute this formula now. So if you want to find what is RA, if you want to find what is RA, then it should be R1, R2 divided by R1 plus R2 plus R3. In denominator it will be same for every values, it will be same. So it will be 4 plus 8 plus 6. Then in numerator it will be R1 into R2, 4 into 8, you will get what? 4 into 8, you will get 20, 32, 32, 32. So you will get at finally RA will be equal to, so RA will be equal to 32 divided by what is this value? 12. This will be 18, right? So 40, 18, 18. So 32 by 18. 32 by 18. Then we can further simplify this. This is 9. This is 16. And anyhow, we cannot go further after that. So if you simplify this, you will get 1.77 ohms. That is RA, right? So now we go for RB. Formula is simple. Formula is simple, right? So RB will be equal to same RA plus R1 plus R2 plus R3. But here if it is RB, then it will be R2 into R3, right? So I will directly substitute now, since we know what is the denominator now. So RB should be equal to the whole divided by, that will be 18, no difference in this. And R2 into R3, what is R2? 6 into 8, right? So 6 into 8 we will get 48, right? So 48. And if I simplify this value, so if I simplify this value, I will get RB is equal to 2.66. Then we will go for RC. So RC will be equal to, so in denominator it will be same, right? R1 plus R2 plus R3. And in the numerator, if this is RC, then it will be R3 into R1 into R1. So R3 is what here? 6 into 4. So 6 into 4 you will get 24 divided by, and in the denominator it will be 18. There is no difference in denominator. So it will be 18. So finally RC will be equal to, the value I am getting is 1.33 ohms. 1.33 ohms. So we have found what is RA, what is RB, and what is RC. See, I will draw the equivalent diagram here itself so that you can easily understand. See, I will draw. See, this is the diagram. See, point A is here, point B is here, point C is here. This delta connection has to be replaced by this star like this in this circuit, right? So this point, these 3 points, that is why I am repeatedly telling you, these 3 points are very important. ABC, you have to keep this ABC fixed, right? So what is this point now? This will be, you come here. See, this is RA, and where is B? That is RB. Where is C? That is RC. That you have to clearly understand, right? See here, in this point, this will be RA, right? Then if it is RA, this will be RA. Anyhow, I will write here. This will be RA. What is RA value? RA is 1.77 ohms, and this will be RB. This point, this resistor. So RB will be equal to, what is RB? 2.66 ohms, and this resistor will be RC. And what is RC? RC is 1.33 ohms. So what I am going to do, I am just going to replace this star connection instead of this delta connection in this circuit. So I will draw the diagram here. You see, we have replaced this delta with a star connection. Now you see this circuit. This will be very simple now. You can easily simplify this one because these two are connected in series. These two are connected in series. So if you add these two resistors, what you will get? You will get 6.66, right? So so I will draw the diagram again. So we can easily do this now. By drawing the diagram itself, we can directly substitute the values, right? So these two are connected in series, so I can draw a single resistor, and these two are connected in series, so I have drawn a single resistor. So these 2 points are connected, right? Since these 2 points are connected here, so what I can do, I can connect these 2 points, and I can also draw another resistor. So what is this value? This is point, maybe this is this we have to draw. So see, this is point A, this is point B, and this is 4 ohms resistor, and this will be 1.77 ohms resistor. There is no difference here. So I will perfectly write it down. So you see, this will be 4. 4 plus 2.66 will give you what? 6.66 ohms. So this will be 6.66 ohms. And what is this resistance? 8 plus 1.33, that will be 9.33 ohms. So 9.33 ohms, right? So this value will be 1.77 ohms. So now you see these two resistors. See, both ends are connected. So these two are connected in parallel, right? These two are connected in parallel, and this is connected with the this 1.77 ohms connected in series with this parallel combination, right? So if I go for parallel combination, so if it is Rp is equal to, what is the total resistance? You have to add in the denominator 6.66 plus 9.33, and in the numerator you have to multiply 6.66 into 9.33, and if you simplify this, so if I simplify this one, I will get Rp is equal to 3.88 ohms. So if I simplify these two resistors parallel connection, I am getting 3.88. So I can replace this parallel combination with 3.88, right? So I will draw the diagram, and you see I have replaced these two parallel combination with 3.88 ohms. Now you see between A and B point, 4 ohms, 3.88 ohms and 1.7 ohm, 1.77 ohms, all are connected in series, right? All three resistors are connected in series. So if I further simplify this, what I can directly write now, resistance between R, A, B will be equal to 4 plus 3.88 plus 1.77 ohms, right? So I will get, if I simplify finally, R A B will be equal to 9.65 ohms. So this is the final answer, right? So final answer. So you see, we have simplified what is the resistance between point A and B. See, this star to delta connection is very important in certain circuits or in few circuits, right? We can say like that, because you see this circuit cannot be simplified with our conventional techniques, since these two resistors are connected in series. But if I simplify this, I will get 12 ohms, no problem with that. Anyhow, if I even that 12 ohms resistors cannot be connected between this point or this point, there is a confusion where to connect this 12 ohms resistor. One point can be connected here, but the other end cannot be connected here or at point C. So there is a problem is coming, right? So we can go for delta connection to star connection, since this connection is connected like delta connection. And also you see these three can be also converted into a star connection, since these three resistance, 4 ohms, 8 ohms and 6 ohms is also connected in a delta way, right? You see this point that can be also connected in a delta. See, I will draw this one anyhow, this point. So you take you just draw like this, and you just draw like this, you just draw like this now, right? So this is 4 ohms resistor, and this is 8 ohms resistor, this is 6 ohms resistor, right? So these three are connected in delta. This can be also converted into star, so that we will get a reverse process. That if you simplify like that also, you will get the same RAB value. That is up to you. You take any delta connection in the circuit, that then you convert that delta connection into a star connection. I have taken this as a delta connection. Anyway, this is also connected like this. So you have to simplify delta connections to star connections like this, right? This will be applied in some circuits to get the equivalent resistance value. So up to this, we have seen star to delta connection equations, and we have taken two different problems, where we have taken one problem we have converted star to delta, and in the another problem we have converted delta to star. So we will start a new topic in the next class. Thank you.